In a cold, silent operating room illuminated by relentless lamps, a woman lies with her skull open, completely awake. There are no screams, no general anesthesia, no possible escape. Around her, doctors observe every reaction with absolute attention. Then the surgeon gently touches the surface of the brain with a small electrical probe, and suddenly the patient speaks. Not about pain, not about fear. She begins to sing a song she had not heard since childhood, a forgotten melody resurrected from some deep place in memory. There was no radio in the room, no one was singing, only a brain stimulated by a minimal electrical current, and a memory coming back to life. In that disturbing instant, a question ceased to be philosophical and became clinical, urgent, and terrifying. If an entire memory can be triggered like a switch, then what exactly are we? Merely electrified flesh? Or something more hidden behind matter? If you want to follow real stories like this, medical discoveries, scientific mysteries, and individuals who challenged everything we thought we knew about the human body, consider subscribing to the channel now. Because some of the most disturbing stories in medicine are yet to come, and many of them sound like fiction, but are not. The man behind this scene was Wilder Graves Penfield, a neurosurgeon born in 1891 in Spokane, Washington, who would become one of the most influential figures in the history of neuroscience. But his journey did not begin in an operating room. It began with an almost impossible ambition planted by his own mother. When he was only 13 years old, she heard about the newly created Rhodes Scholarship and decided that her son should win it. To do so, he would need to become a complete man. Athlete, scholar, leader, intellectual. The problem is that Penfield himself would later admit he was not naturally brilliant, nor particularly gifted physically. He described himself as a plodder, someone who advances slowly through discipline, not instant genius. Perhaps it was precisely this perseverance that took him to Princeton, then Oxford, and finally to medicine, the profession of his grandfather and his distant father, chosen because it seemed the most direct way to make the world a better place to live. The Europe he encountered during his formative years was on the brink of collapse. World War I transformed universities into improvised hospitals and young students into soldiers. Penfield witnessed devastating injuries to the head and nervous system, wounds that often left survivors with severe epilepsy. At the time, little was known about the disease. Some physicians still believed seizures were essentially inexplicable. Others attributed them to moral or psychological causes. The brain remained largely unknown territory. It was in this context that Penfield began to suspect something radical. Perhaps epilepsy was not a diffuse phenomenon, but a localized problem, an electrical storm starting at a specific point in brain tissue. After training with giants of medicine such as William Osler, Harvey Cushing, and neurophysiologist Charles Sherrington, Penfield decided to dedicate his career to exploring this mystery. In 1928, he moved to Montreal with his surgical partner William Vernon Cohn, drawn by the opportunity to build something that did not yet exist, an institute where clinicians, surgeons, and scientists could work side by side to understand the human brain. With support from the Rockefeller Foundation and Canadian authorities, this dream materialized in 1934 with the inauguration of the Montreal Neurological Institute, which would quickly become a global center for neurological research. It was there that Penfield refined the method that would make him famous and controversial. To treat severe, intractable epilepsy, he removed part of the patient's skull under local anesthesia, keeping them conscious. The reason was simple and terrifying. The brain itself does not feel pain, but only the patient could report what was happening inside it. During surgery, Penfield stimulated different areas of the cortex with an electrical probe and asked the patient to describe any sensation, image, or emotion that arose. Each response was a clue, each reaction a point on an invisible map. The early results seemed to confirm his hypotheses. Certain regions produced specific movements, others tactile sensations, still others speech disturbances. Thus emerged one of the most iconic concepts in neuroscience, the cortical homunculus, a distorted representation of the human body based on how much brain area is devoted to each function. Lips and fingers, rich in nerve endings, occupy enormous regions, the trunk and legs much less. For the first time in history, the human brain was beginning to reveal its functional organization with precision. But when Penfield stimulated the temporal lobes, the investigation ceased to be merely scientific and began to touch something almost existential. Patients reported complete experiences, not fragments. One woman heard an orchestra playing a specific piece of music. Another described seeing a childhood scene with vivid colors and details. A man smelled intense burnt toast, exactly the same odor that preceded his seizures. These experiences were so realistic that many patients believed they were actually happening at that moment. Even more intriguing, when the exact same point was stimulated again, the same experience returned, identical, like a recording played once more. These observations suggested something revolutionary. Memories might have a localized physical basis, an engram stored in brain tissue, yet at the same time they raised disturbing questions. Who was watching this memory being replayed? If the brain can generate a complete experience, is it still possible to distinguish memory from reality? And even more unsettling, to what extent does our identity depend on these biological recordings? While exploring these questions, Penfield also encountered the limits of science itself. Despite thousands of electrical stimulations applied to the human brain over decades, he never succeeded in provoking deliberate abstract reasoning. No patient suddenly began solving complex mathematical problems or reflecting on philosophy spontaneously. Even during epileptic seizures, symptoms were always concrete. Movements, sensations, images, emotions, never structured logical thought. For a researcher trained in a materialist paradigm, this was deeply perplexing. Another phenomenon reinforced this unease. During surgeries, Penfield often asked patients to move a limb voluntarily. Then he stimulated the corresponding motor area, causing the limb to move involuntarily. He would then ask, "Did you do that, or did I?" Patients invariably knew the difference. There was an unmistakable sense of authorship when the movement was voluntary, something that could not be reproduced by electrical stimulation. Penfield concluded that he could activate muscles but not will. He could produce behavior but not intention. His personal life was also marked by dramatic episodes that shaped his scientific outlook. In one particularly anguishing moment, he operated on his own sister to remove an aggressive brain tumor. The surgery was technically successful but required removing a large portion of the frontal lobe. After recovery, she appeared relatively normal, until small details revealed profound changes. She struggled to plan simple tasks, organize activities, or anticipate steps in an action. It was a painfully concrete demonstration of the frontal lobe's role in personality and executive behavior. 2 years later, the tumor returned and killed her. For Penfield, the line between scientific progress and human suffering was never abstract, it was personal. Throughout the 1940s and 1950s, his work received extraordinary international recognition. He was decorated by several countries, became a member of prestigious scientific societies, and was often called the greatest living Canadian. Yet as he aged, his attention shifted from surgical technique to deeper philosophical questions. The brain, despite all advances, remained an enigma. How do electrochemical processes produce consciousness? How does a network of neurons generate the sense of a continuous self over time? In his later years, Penfield wrote extensively about the so-called mind-brain problem. Rather than offering definitive answers, he expressed growing perplexity. Decades of investigation had shown that the brain was necessary for the mind, but perhaps not sufficient to explain it completely. He did not claim that the mind was independent of matter, but he acknowledged that the relationship between the two remained profoundly mysterious. Today, nearly half a century after his death in 1976, Penfield's legacy endures. The Montreal Neurological Institute is still a world-class center. Awake surgeries continue to be performed to treat epilepsy and tumors, often saving lives or preserving essential functions such as speech. Brain maps have become more detailed thanks to technologies like functional MRI and deep brain stimulation. And yet, the central question remains almost unchanged since Penfield's time. The brain can explain how we perceive the world, but not why there is a subjective experience of that perception. It can describe neural circuits associated with memory, but not who remembers. It can correlate electrical activity with decisions, but not explain the intimate feeling of choosing. Perhaps that is why Penfield believed that understanding the brain ultimately meant understanding the human being itself. Perhaps the most unsettling aspect of his story is not what he discovered, but what he could not discover. After thousands of surgeries, countless hours of observation, and some of the boldest techniques ever applied to the human brain, the fundamental mystery remained intact. If the brain is merely a biological organ, why does it produce something as immaterial as consciousness? If we are only organized matter, why do we feel like something more than that? And if you made it this far, don't leave before subscribing to the channel. Think of it as marking a point on the map of a much larger journey, because every story we explore is an attempt to illuminate unknown regions of human knowledge. Some reveal answers, others only deepen the mystery, but they all share one thing. They show that reality can be far stranger and more fascinating than any fiction.